Children spend a large portion of their day indoors at school. Ensuring that schools have good indoor air quality is critical to protecting and supporting the health and well-being of students, staff, and teachers. When thinking about indoor air quality, it is important to understand that pollutants can originate both indoors and outdoors. Indoor pollutants include volatile organic compounds like formaldehyde that can off-gas from building materials, finishes, furniture, and cleaning products. Indoor pollutants also include respiratory aerosols that are exhaled by building occupants. Reducing the concentration of respiratory aerosols inside buildings mitigates the spread of airborne infectious diseases, including COVID-19. Outdoor pollutants include fine particulate matter less than 2.5 microns in diameter, also called PM2.5. This particulate matter can penetrate deep into the lungs when inhaled. PM2.5 comes from a variety of sources, including fires, power plants, and vehicle exhaust. Ventilation means providing outdoor air into classrooms. Ventilation removes indoor air pollutants from buildings by bringing in outside air and removing or exhausting room air. This dilutes the concentration of indoor pollutants. Please watch our video on ventilation for more information on its importance and benefits. Ventilation works together with filtration to improve indoor air quality. Filtration can capture and reduce exposure to some indoor and outdoor pollutants. In this video, we're going to cover the basics of mechanical filtration. In mechanical filtration, a fan moves air across a filter media. A fraction of the particles are trapped in the media and removed from the air. Let's take a look inside a typical heating, ventilation, and air conditioning, or HVAC system to see how an air filter works. The fan inside the HVAC system draws air from both the room and outdoors for ventilation. This air mixes and is drawn through an air filter where some of the particles in the air are removed. Then, the air goes through the fan and may be heated or cooled before it is returned to the room. In order for a filter to work, the HVAC fan must be running even when no heating or cooling is needed. The performance of a filter is defined by the minimum efficiency reporting value, or MERV. Filters with a higher MERV rating remove a greater fraction of small particles each time the air passes through them. The MERV rating is printed on the side of a filter. Let's look more closely at what a MERV rating means. Here is a plot that shows the approximate fraction of particles of various sizes that are removed each time the air passes through a filter. Each curved line corresponds to a different MERV rating. You might think the smallest particles are the hardest to remove. However, it's actually particles in the 0.05 to 0.5 micron range that are the most difficult to remove. MERV 8 filters were commonly used in HVAC systems prior to the COVID-19 pandemic. A minimum of MERV 13 filtration is now recommended to reduce the spread of airborne infectious disease. Each time the air passes through, a MERV 13 filter removes a higher fraction of the most difficult to remove particles than a MERV 8 filter. Note that some HVAC systems are designed to use multiple filters in a series. In this case, the MERV rating of the system is the MERV for the filter with the highest rating. The MERV ratings do not add together. Only use multiple filters in a series if your system is designed to do so. Filters inside of HVAC systems are inserted into a slot or frame that holds the filter. It is important to ensure that the filters are the correct size, including length, width, and depth. The side of the filter will have arrows indicating the correct direction of airflow through the filter. They must be installed correctly so there are no gaps that allow the air to bypass the filter. Filters should be changed every 3 to 4 months. Technicians should wear appropriate personal protective equipment when changing and disposing of filters to avoid inhaling loose particles. MERV 13 filters are widely available that fit into 1 or 2-inch deep filter slots. You may be concerned that a fan motor not originally designed to work with a MERV 13 filter could struggle with the additional resistance. Filter manufacturers address this concern by making lower pressure drop, high-capacity versions of MERV 13 filters that have more pleats in the filter media. For example, in a report by the California Energy Commission, a MERV 13 filter from one manufacturer had a pressure drop of 0.26 when tested at an air velocity of 300 feet per minute. By comparison, a MERV 13 filter from a different manufacturer had a pressure drop at the same air velocity speed of 0.17, a 35% reduction. In some cases, a MERV 13 filter might actually have a lower or similar resistance compared to a MERV 8 filter. When purchasing filters, request filter resistance data from the distributor and inquire about low-resistance models. A filter with an increased number of pleats will reduce filter resistance and increase the time between filter changes. Ensure that MERV 13 filters are compatible with your HVAC system by using a skilled, trained, and certified technician to measure airflows, system pressures, and fan motor performance, and confirm they meet your system design. Improving the filtration in a central HVAC system is generally the most effective and lasting way to improve indoor air quality. However, portable air cleaners may be used to supplement filtration. For recommendations on portable air cleaners, please visit our website. Remember, the best indoor air quality is achieved when you combine adequate ventilation with MERV 13 or better filtration. Make sure filters are installed in the correct direction and fit properly with no gaps. Consider low-pressure drop versions that will work with most HVAC systems. Change filters every 3 to 4 months. Ensure that your MERV 13 filters are compatible with your HVAC system by using a skilled, trained, and certified technician to measure airflows, system pressures, and fan motor performance, and confirm they meet your system design. Ensuring adequate filtration and ventilation in classrooms is essential and will help support the health and productivity of students and teachers.